Right now, I'm going to show a model of the expansion of the universe using a balloon and some dots drawn on this balloon, which basically represent galaxies when the universe was at a very young age, let's say 100,000 years. So you see how close these galaxies are together right now, right? Because this is at the beginning of the universe, the galaxies were all really clustered up, basically really close together, much closer than they are right now. And so what I'm going to show is, as the universe expanded, the galaxies, they went farther and farther apart from each other. So we can actually see this through telescopes. So if we see through Earth through a telescope and we look at other galaxies, they'll look like they're moving away from us. It'll look like every galaxy around is moving away from us, when in reality we're also moving away from every galaxy due to the expansion of the universe. When the galaxies we observe move further away from us, we know that they're moving further away from us because their light takes longer to reach us, right? And so due to the expansion of the universe, the light is stretched out. Longer wavelengths means light is like at the lower ends of the spectrum. So at infrared, microwaves, radio waves, basically like that. And so this is called Doppler shift. And we can even notice this with sound waves too. Like, this is a classic example in astrophysics. But when an ambulance passes by you, it's getting closer to you, the wavelengths, they're getting shorter, right? So it gets more high pitched. And then when it's moving away from you, the pitch gets much lower because the sound waves are getting stretched. Basically, that's what happens with light too. The light that galaxies emit, it gets stretched as it reaches us. So, and that's why we have to use infrared telescopes to see much more distant galaxies. And this is what the James Webb telescope does, space telescope does. It's able to see very distant galaxies because it's an infrared telescope. So, these are some dots I've drawn. Let's say this is a local galaxy group, like the Milky Way Andromeda Triangulum group. Then here on the other side, I have some dots as well. And so, notice the distance it's at right now. And then when I inflate it right now, so me inflating it will represent the universe expanding. So, let's say this is 100 million years after the Big Bang. Now, what you'll see is, you see here the galaxies, they're farther apart than they were before, right? Just notice this. Much farther than before. Yeah, so basically what the universe expansion does is it makes the galaxies like way more far apart from each other. This is what makes the universe much colder over time, as the universe expands, and it's also what makes the universe black. Like, people might wonder why space is black, and it's because as the universe expands, galaxies, they get farther apart, so less light is actually like traveling around the universe because there's more space. Like, light is fast, but the universe is bigger. So yeah, that's basically it. And here, I've got some more dots. I'll be expanding it more because it can get much bigger than this. I'm gonna start over. Now let's see how far apart they are. The dots are very faint now because of the universe's expansion, but you can see they're much farther apart now. Look at these dots. These were most likely close together at first when I drew them, and so now look how far apart they are. Same. It's getting much harder to see actually. But I'll try to find some. Yeah, you don't see any galaxies close together. Well, this, I made a little mistake drawing this. That's not supposed to be a galaxy, but you see how each one is much more distant than it was before. So yeah, that's basically a model, just a little basic model you can do at home too, and show it to people. Yeah, that's it. Thank you.